So the number of relations from A to B is 2 to the power of number of elements in A into number of elements in B. 1, 2 and 2, 1 implies 1, 1 does not belongs to R. So therefore this is not a transitive. A function which is both 1, 1 and on 2 is called as a bijective function. If T1 is congruent to T2 and T2 is congruent to T3 implies T1 is also congruent to T3. Therefore R is a transitive. Hello dear students, welcome to this session of second PUC Mathematics revision class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take the revision of the first chapter. So in this session I am going to discuss regarding the weightage for this chapter as well as some important questions in 1 mark, 2 marks and 3 marks. Now let us come to the weightage. What is the weightage of this chapter? So in this chapter you are going to get one 1 mark question, one 2 mark question and one 3 mark question and one 5 marks question. So totally 1 plus 2 plus 3 plus 5. So 5 plus 3 8 plus 2 10 plus 1 is 11 marks. So the weightage for this chapter is 11 marks. That means in all sections, part A, part B, part C and part D. So in part A you will get one question, and in part B one question, and in part C one question, and in part D one question. So totally 4 questions in all the parts A, B, C, D. You will get one question from this session. Now before going to the exact concept, so in this chapter we are going to study regarding the ordered pair and relations, functions, different types of relations, then different types of functions, the problems based on different types of relations and functions. You might have been studied regarding different types of relations like reflexive relation, symmetric relation and a transitive relation, and in different types of functions, one functions, onto function, bijective function, and then few problems based on the composition of a function, that is Fogg and Goff function, then the binary operations, problems based on binary operations like and the properties of binary operations like commutative property, associative property, identity property and inverse property, and the problems for 1 marks, 2 marks and 3 marks. Those are the things which we are going to study in this session. Now let me come to the first 1 mark question. So that is a relation or on a set A and B is a subset of A cross B. A relation or on a set A and B is the subset of A cross B. What is A cross B? A cross B is nothing but the set of all ordered pairs in which first member is an element of set A and second member is an element of set B. A comma B, X comma Y, 1 comma 2. They are called as the ordered pair in which first member is an element of the set A and second member is an element of the set B. So the set of all ordered pairs, a relation or on a set A and B is a subset of A cross B is called the relation denoted as capital R. Now let us take an example. If A is equal to 1, 2, 3, B is equal to 2, 3, 4, define a relation R from A to B as, what is the condition given? X comma Y such that X is less than Y. A relation R from A to B is defined as X comma Y such that X is less than Y. That means first number is less than the second number. Now write down the cross product of this A and B. A cross B is equal to the Cartesian product of A and B. So 1 comma 2, 1 comma 2, then 1 comma 3, then 1 comma 4. Similarly 2 comma 2, 2 comma 2, then 2 comma 3, 2 comma 3, 2 comma 4, then 3 comma 2, 3 comma 2, 3 comma 3, 3 comma 3 and 3 comma 4. So this is the Cartesian product of A and B. A cross B is, this is A cross B. Now what is the condition given? R is equal to X less than Y, the relation. So first number is less than the second number. We can take 1 comma 2, 1 comma 3, 1 comma 4. That means 1 is less than 2, 1 is less than 3, 1 is less than 4. We cannot take 2 comma 2, 2 is less than 3, 2 is less than 4. We cannot take 3 comma 2 because 3 is greater than 2, 3 comma 3 we cannot take 3 comma 4. So 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 1, 2 comma 3, 2 comma 4, 3 comma 2, and we cannot take 3 comma 3 here. So the relation, what is the relation? Let me explain. Here this is the sub A cross B, this is nothing but A cross B. Now from this A cross B, find out the relation R which satisfies the given condition X is less than Y. So 1 is less than 2, 1 is less than 3, 1 is less than 4. Again we cannot take 2 is greater than 1, 2 is less than 3 we can take, 2 is less than 4 we can take, 2 is also less than 4 we can take this element also, and 3 is greater than 2 we cannot take this, 3 comma 3 we cannot take this, and we can take 3 comma 4. So therefore R is equal to 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 3 comma 4, and even 2 comma 4 we can take. So therefore the relation is given by R is equal to 1 comma 2, then 1 comma 3, then 1 comma 4. Again we cannot take 2 comma 2, 2 comma 3 we can take, 2 comma 4, again 3 comma 2 we cannot take, 3 comma 3 we cannot take, 3 comma 4. That's it. So this is the example for the relation. So this R is a subset of A cross B. So the subset of A cross B is called the relation. Now let us take an example. Therefore R is the subset of A cross B and it is called a relation. Now let us come to the next concept. Now the number of relations from A to B. Suppose if a set A contains, if the number of elements in a set A is M and the number of elements in a set B is N, then the number of relation from A to B is 2 to the power of number of elements in A into number of elements in B. That is nothing but if the number of elements, if number of elements in A is M and the number of elements in B is equal to P, then the number of relation from A to B is always is equal to 2 to the power of M into P. That is nothing but 2 to the power of number of elements in A into number of elements in B. So that is nothing but, suppose if M and N are the number of elements in A and B, then we can also write 2 to the power of Mn number of relations from A to B. Similarly, number of relations on a set A itself. Suppose if there is only one set, the number of relations on a set A to A itself is 2 to the power of N of A into N of A. That is nothing but if a set A contains number of elements in set A is equal to M, then the number of relations from A to A is given by 2 to the power of M into M. That is nothing but 2 to the power of M square. That's it. That is, so the number of relations from A to B is 2 to the power of number of elements in A into number of elements in B. So the number of relation on A to A is nothing but 2 to the power of N of A into N of B. That is 2 to the power of N square, 2 to the power of M square or N square. Now let us take an example. This is 1 mark question. You may expect this type of questions for 1 mark. Find the number of relations on the set A is equal to 1 comma 2. See here, how many number of elements are there? The number of elements in A is 2. So therefore we can write the number of relation from A to A is 2 to the power of 2 into 2. That is 2 into 2 is 4. 2 to the power of 4 is 2 to the 4, 4 to the 8, 8 to the 16. So the number of relation from A to A for 1 comma 2, 2 elements is 2 to the power of 4. That is 16 relations we can write. Now similarly, find the number of relations from A to B where A is equal to 1, 2, 3 and B is equal to 5 comma 6. So here the number of elements in A is equal to 3 and the number of elements in B is equal to 2. The number of relations from A to B is 2 to the power of Mn, that is 2 to the power of 3 into 2 is 6, 2 to the power of 6 is 64, 2 2s are 4, 4 to the 8, it is a 16, 16 2s are 32 into 2 is 64. That is 2 into 2 into 2 6 times, 2 into 2 into 2 into 2 into 2 into 2. Now multiply this. 2 2s are 4, 4 to the 8 is 16, 16 2s are 32, 32 into 2 is 64. So the number of relations from A to B is 64. Right. See the difference. Here the number of relations from A to A. Here the number of relations from A to B. So in both the cases, it is 2 to the power of M into N. That is 2 to the power of 2 into 2 is 2 raised to 4 is 16. 2 to the power of 3 into 2 is 2 raised to 6 is 64. That's it. Now let us take next problem for 1 mark. So you may expect this type of questions for 1 mark. Show that the relation R in the set 1, 2, 3 given by R is equal to 1, 2 and 2, 1 is symmetric but neither reflexive nor transitive. Now just recall the properties of a reflexive, symmetric and transitive. What is reflexive? A relation R on a set A is called a reflexive. It is reflexive relation. Reflexive means if A comma A belongs to R, for all A belongs to A, if A comma A belongs to R, then it is called a reflexive. What is symmetric? Symmetric relation means if A comma B belongs to R implies B comma A also belongs to R. If A comma B belongs to R, then B comma A also belongs to R. Then what is transitive relation? Transitive means if for all A comma B comma C belongs to R, if A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R, then it is called a transitive. So reflexive, A comma A belongs to R. Symmetric, A comma B belongs to R implies B comma A also belongs to R. And reflexive, symmetric, then last one is the transitive. If A comma B belongs to R and B comma C belongs to R, then A and C also belongs to R. That means if A is related to B and B is related to C implies A is also related to C. Now here check, show that the relation R on the set, what is given? R is equal to 1, 2 and 2, 1 is symmetric but neither reflexive nor transitive. What is the reflexive property? A comma A, 1, 1, 2, 2. So 1, 1 does not belong to R. So therefore this is not reflexive. This is not reflexive. This is not reflexive. Now symmetric. What is symmetric? If 1, 2 belongs to R implies 2, 1 also belongs to R. This is example. So therefore this is nothing but if A comma B belongs to R implies B comma A belongs to R. So therefore R is symmetric. This is symmetric. And if we consider the transitive property, so 1, 2 and 2, 1 implies 1, 1 does not belongs to R. So therefore this is not transitive. Transitive, as because if A comma B belongs to R and B comma C belongs to R implies A comma C does not belongs to R. So if 1, 2 belongs to R and 2, 1 belongs to R implies 1, 1 does not belongs to R. Therefore this is not transitive. Hence the given relation, this is symmetric but neither reflexive nor transitive. This is only symmetric but neither reflexive nor transitive. Now move on to the next problem. What is next one is define a binary operation. These are all 1 mark questions. Define a binary operation. Now what is a binary operation? A binary operation star on a set A is the function star from A cross A to A is denoted as star A comma B by A star B. It's nothing but a function star from A cross A to A. That is, a binary operation star on a set A is a function star from A cross A to A is called a binary operation, and it is denoted, star is called the binary operation and it is denoted by star A comma B by A star B. This is very important definition. In the examination for 1 mark they must define a binary operation. So a binary operation star on a set A is a function star from A cross A to A. So that is denoted as star A comma B by A star B. Now let us take an example. On the set of natural numbers n is equal to 1, 2, 3, 4, etc. On the set of natural numbers, let us consider addition. This is an example. Plus, so for all A comma B belongs to n, so for all A comma B belongs to n, for all A comma B belongs to n, if A comma B belongs to n, that is, let us take A is equal to 1 plus 2 is equal to 3 belongs to n. So what you say, therefore addition is a binary operation on the set of natural numbers. Suppose if I consider the difference subtraction, if a star b is defined by a star b is equal to a minus b for all a comma b belongs to n, let us take a is equal to 1, b is equal to 3, then a star b is equal to a minus b, that is 1 star 3 is equal to 1 minus 3 is equal to minus 2 does not belongs to n. You can say that star is not a binary operation, not a binary operation on n. That means subtraction, here the subtraction is not a binary operation on n. Even division, if you take 1 by 2, 1 by 3, so its division is not also a binary. That means here it's a rule. See, it's a rule in which if you combine any two elements of the set, you will get one more element that is also included in the set, means then it is called a binary operation. That's it. Okay. Now move on to the next one. In the binary operation, you may expect this type of question. Let's start with a binary operation on n given by a star b is equal to LCM of a and b. Find 5 star 7. Very important problem for 1 mark. So a star b is defined by LCM of a and b. So a star b is equal to LCM of a and b. Now then what is 5 star 7? 5 star 7 is equal to LCM of 5 and 7. 5 and 7. So LCM of 5 and 7 is equal to 35. That's it. LCM of 5 and 7 is 35. Let us take one more example. Suppose if a star b is defined by LCM of a star b is equal to LCM of a and b, then find 4 star 20, the LCM of 4 and 20. So LCM of 4 and 20, a star b is equal to LCM of 4 and 20, that's equal to 4 and 20. So let us start with the 4 itself. 4 ones are 4 5s are, again 5 ones are. So 4 into 5, that's equal to 20. So the LCM of 4 and 20 is equal to 20. So if you do this much, definitely you will get 1 mark. That's it. Okay. Move on to the next problem. So even for 1 mark on the binary operation, you may expect this type of question. Let's start with the binary operation on the set Q of rational numbers given by a star b is equal to ab by 2. Show that star is commutative. You know the laws of binary operation, commutative law and associative law. What is commutative law? Commutative law. Commutative law means for all a comma b belongs to the set, if a star b is equal to b star a, then it is called commutative. And what is associative law? You might have studied associative law. Associative law, if for all a comma b comma c belongs to the set, if a comma b comma set belongs to the set yes, here for all a comma b belongs to yes, set yes, if a star b star c is equal to a star b star c, then star is called associative. Now what is the problem given? Let's start with the binary operation on the set of rational numbers given by a star b is equal to ab by 2. Show that star is commutative. Now what is commutative property? Commutative property, commutative law, that is for all a comma b belongs to the set yes, if a star b is equal to b star a. Now what is given? A star b is equal to, here a star b for all a comma b belongs to q, a star b is equal to ab by 2, and similarly b star a is equal to ba by 2. So here ab by 2 is equal to ba by 2, divide by 2 gets cancelled, ab is equal to ba, a into b is equal to b into a. So therefore star is commutative. On q, star is commutative. So commutative property holds good. Star is commutative on q, that is commutative law is satisfied or commutative property holds good. So a star b is equal to b star ab by 2 is equal to ba by 2, or ab is equal to ba. So if you do this much, you will get 1 mark, right? If they ask to find verify the associative property, means just verify A star B star C is equal to A star B star C. For that you will get 1 more marks, totally you will get 2 marks, right? Now let's come to the next. Now let's move on to the 2 marker questions. So what are the 2 marker questions? Usually you may expect again 2 marks from the relations. Show that the relation R on the set 1, 2, 3 is given by 1, 1, 2, 2, 3, 3, 1, 2 and 2, 3 is reflexive but neither symmetric nor transitive. So you know what is reflexive means? A, A. That means verify whether this set contains 1, 1, 2, 2, 3, 3. Then it is reflexive. Symmetric, if 1, 2 is there means 2, 1. 1, 3 means 3, 1. So 2, 3 means 3, 2. Then it is called symmetric. And transitive, if A, B and B, C belongs to R implies A, C belongs to R, then it is called transitive. Now let us go on verify. What is given here? R is given by the relation R is given by 1, 1, 2, 2, 3, 3 and 1, 2 and 2, 3. Now clearly you can say that 1, 1, 2, 2, 3, 3 belongs to R. That means A belongs to R, therefore R is a reflexive. Since 1, 1 belongs to R and 2, 2 also belongs to R, 3, 3 also belongs to R, that is A, belongs to R. A belongs to R. Therefore, R is reflexive. R is reflexive. So, R is reflexive. Now, let us come to the second one. What is the second condition? Symmetric. Symmetric. What is symmetric? That is, if on R, if for all A, B belongs to R, if A, B belongs to R, implies B, A also belongs to R. Now let us take 1, 2 here. So here 1, 2 belongs to R, 1, 2 belongs to R, implies 2, 1 does not belongs to R. Similarly, 2, 3 belongs to R, but 3, 2 does not belongs to R. So therefore R is not symmetric. This is not symmetric. R is not symmetric. Now verify the transitive property. Third one. What is transitive? Transitive property. So reflexive but neither symmetric nor transitive. Verify whether it is transitive or not. What is the condition for transitive? If A, B belongs to R and B, C belongs to R, implies A, C also belongs to R. Now let us take 1, 2. 1, 2 belongs to R and 2, 3 belongs to R. So 1, 2 belongs to R and 2, 3 belongs to R implies, so 1, 3 does not belongs to R. So here 1, 3 is not in the set. So if 1, 2 and 2, 3 belongs to R implies 1, 3 does not belongs to R. Therefore, R is not transitive. R is not transitive on R. So the given relation is only reflexive, neither symmetric nor transitive. So if you do this much, you will get 2 marks. Sometimes they may ask this question for 3 marker also, right? Now move on to the next type of problem. So this is a problem from types of function. What is the problem given? Show that the function f from n to n is given by f of x is equal to 2x is 1 function. So you know the definition of 1 function. A function f of x is said to be 1 function if f of x1 is equal to f of x2 implies x1 is equal to x2. If for all x1, x2 belongs to n, f of x1 is equal to f of x2 implies x1 is equal to x2, then it is called 1 function. What is given? F of x is equal to 2x. Let for all x1, x2 belongs to n, f of x1 is 2x1 and f of x2 is equal to 2x2. Now f of x1 is equal to f of x2 implies, what is f of x1? 2x1 is equal to 2x2. 2 gets cancelled, x1 is equal to x2. That means if f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1 function. That's it. If you do this much, you will get 2 marks. f of x is 1, 1. That is, f of x1 is equal to f of x2 implies 2x1 is equal to 2x2 divided by 2, x1 is equal to x. So that means this condition is satisfied. F of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1, 1 function. Now let us take one more problem like this. Show that the function f from R to R is given by f of x is equal to 2x is 1, 1 and R2. Now we have to verify whether it is both 1, 1 and R2. As usual, let for all x1 comma x2 belongs to R, let us take f of x1 is equal to 2x1 and f of x2 is equal to 2x2. Now let us verify first 1, 1 function, whether it is 1, 1 or not. What is 1, 1? F of x1 is equal to f of x2. That is 2x1 is equal to 2x2 implies x1 is equal to x2. That means f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1, 1 function. First condition is satisfied. F of x is 1, 1. Right. Now verify whether it is onto or not. For any real number, for all y belongs to R, there exists f of x such that f of x is equal to y. For all y belongs to R, there exists f of x such that f of x is equal to y. What is f of x is given? F of x is 2x is equal to y and x is equal to y belongs to R such that f of x, what is f of x here? F of x is nothing but y by 2. Y by 2. What is f of y by 2? Since f of x is equal to 2x, f of x is equal to 2x, just replace x by 2. You will get 2 into x by y by 2, 2 into y by 2. 2 and 2 is equal to y belongs to R. So, f of x is equal to y. So, that is, therefore, f of x is an onto function. F of x is an onto function. See? So, for all y belongs to R, there exists an f of x is equal to y such that f of x is equal to y, that is 2x is equal to y, where x is equal to y by 2 belongs to R. So, such that f of x is equal to f of y by 2, substitute y by 2 in place of x, 2 times y by 2, 2 gets cancelled, y belongs, that means f of x is equal to y. This condition is satisfied. Therefore, f of x is an onto function. So, you can say f of x is both 1, 1 and onto. A function which is both 1, 1 and onto is called as a bijective function. That we will discuss in 5-marker questions. Now, let us take to the next problem. So, these are all 2 marks. Just I am discussing regarding 1 mark, then 2 marks and 3 marks possible questions which may appear for the final examination. So, suppose if f from A to B, these are the problems from composition. If f from A to B is a function, f from A to B, this is A and B, f from A to B is a function. And again g from B to C is another function, this is C. G from B to C is another function, so this is C. So this is f and g. Then a function from A to C is called the composition, denoted as g naught f or f naught g. This is called as the composition of a function. Now let us come to this. What is given? If f of x is equal to 8x cube, g of x is equal to x to the power of 1 by 3, find g naught f and f naught g. Now let us come to the first one, g naught f of x. G naught f of x is equal to g of f of x. So this is g of, what is f of x? F of x is 8x cube. Right. Since what is g of x? We know g of x is equal to x to the power of 1 by 3. So this is g of x is nothing but what is x? Let us consider this as x. That is 8x cube to the power of 1 by 3. So this is 8 to the power of 1 by 3 and x cube to the power of 1 by 3. What is this equal to? 8 to the power of 1 by 3 can also be written as 2 cube. 2 to the 4, 4 to the 8. So, and this is x cube to the power of 1 by 3. 3 gets cancelled. This is 2 to the power of 1 is x to the power of 1 is x. So, g naught f of x is equal to 2x. Right. Now, come to the second part. What is the second one? Fog. F naught g of x is equal to f of g of x. That is f of, what is g of x? G of x is x to the power of 1 by 3. since what is f of x? F of x is 8x to the power of 1 by 3. So here just replace. So f of x is equal to 8x to the power of 1 by 3. So if you want, you can also take, let us consider this as, I will teach one more method. Let us call it as f of k, where k is equal to x to the power of 1 by 3. Since what is f of x is 8x to the power of 3, f of k can be written as 8k cube. 8 into, substitute the value of k. What is k here? You have taken x raised to 1 by 3 whole raised to 3. 3 and 3 gets cancelled. This is equal to 8x. So f naught g of x is equal to 8 times x you will get. So this is how we are going to solve this composition of the function. See here, f naught g of x is f of g of x. F of g of x is x to the power of 1 by 3. Let us call this as k, f of k, where k is equal to x to the power of 1 by 3. What is f of x? 8x cube can also be written as 8k cube. If x is replaced by k, then that is k to the power of 3, 8k cube. So 8 into, what is the value of k? X to the power of 1 by 3. So 3 gets cancelled, 8x. This is how we are going to solve this. Now move on to the next problem. Same type problem. This is very important. Even this may ask for 3 marker also. Now what is the problem given? If f from R to R is given by f of x is equal to 3 minus x cube whole raised to 1 by 3, then find f naught g of x. So f naught f of x. What is f of x? 3 minus x cube whole raised to 1 by 3. Now f naught f of x can be written as f of x. This is f of function of x is nothing but 3 minus x cube whole raised to 1 by 3. Now let us call it as k, f of k, where k is equal to, let me take k. What is k? K is equal to 3 minus x cube whole raised to 1 by 3. Since f of x is equal to this much, if I replace x by k, f of k is equal to 3 minus k cube whole raised to 1 by 3. So f of k can be written as 3 minus k cube whole raised to 1 by 3. Now this is 3 minus, just replace k, that's all. What is k? K is equal to 3 minus x cube whole raised to 1 by 3 whole raised to 3 whole raised to 1 by 3. So here this 3 and 3 gets cancelled. This is equal to multiply by minus 3 minus into minus plus x cube whole raised to 1 by 3. Minus 3 plus 3 gets cancelled. This is equal to x cube to the power of 1 by 3. So this is equal to x. So therefore we can say that f naught f of x is always equal to x. In the examination they may ask if f of x is equal to 3 minus x cube whole raised to 1 by 3, if f from R to R is a function, then show that f naught f of x is equal to x. That's it. This is how we are going to solve this problem, right? Now move on to the next problem, that is again from binary operation for a 2 marker. Now let star be a binary operation on the set Q of rational numbers given by a star b is equal to ab by 4. Show that star is both commutative and associative. So we have to verify whether star is associative as well as a commutative. So now let us come to the first property, commutative law. What is commutative? If for all a comma b belongs to Q, a star b is equal to b star a. Verify if this property is satisfied, then it is called a commutative. So what is a star b? A star b is equal to ab by 4 and b star a is also equal to ba by 4. You can write ab is equal to ba. So what you say? Therefore star is commutative. Star is commutative on Q. So commutative property is satisfied. Commutative law holds good. Now on the other hand, verify associative property. Now what is second one? Associative law. Associative law or associative property. What is the property? For all a comma b comma c belongs to Q, if a star b star c is equal to a star b star c, then associative property is satisfied or associative law holds good. Now let us take LHS. LHS a star b star c. Since what is a star b given? A star b is equal to ab by 4. Now If this is equal to A star, if A star B is equal to AB by 4 means B star C can be written as BC by 4. Let us call it as X, where X is equal to BC divided by 4. Let me explain one step in detail. A star BC by 4, call it as X, then A star X. If A star B is equal to AB by 4 means A star X can also be written as AX divided by 4. This is A by 4 into what is X? BC divided by 4. This is equal to ABC divided by 4. 4s are 16. That means A star B star C LHS. A star B star C is equal to ABC by 16. Let us represent this as equation number 1. On the other hand, let us take RHS. A star B star C. Now, what is A star B? A star B is equal to AB by 4 star C. Let us call it as Y star C, where Y is equal to AB by 4. So, if Y star C can also be written as YC divided by 4. C by 4 as it is. What is Y? AB divided by 4. This is equal to ABC divided by 16. So, therefore, what is say? A star B star C, A star B star C is equal to ABC divided by 16, equation number 2. So, what is say from equation number 2? A star B star C is also equal to A star B star C. That is ABC by 16, LHS is equal to RHS. From 1 and 2, we can say that LHS is equal to RHS. Therefore, from 1 and 2, we can say that A star B star C is equal to A star B star C. Therefore, star is associative on Q. That means associative property is satisfied. So, if you do this much, sometimes you may get 2 marks for this and 1 mark for that, 3 marks, or 1 plus 1, 2 marks for this. This is how we are going to solve the problems based on binary operations like associative property and commutative property. Suppose if in the examination, if you want to find the identity and inverse element, so for identity you might have been studied, the identity is given by A star E is equal to A or E star A also equal to A, where E is the identity element. For existence of inverse element, A star A inverse is equal to A inverse star A is equal to A. So, using these two properties, you can find the identity element or inverse element, right? Now, let's move on to the next problem for 3 markers. Just now we have solved regarding reflexive, symmetric and transitive properties. Suppose if a relation R is reflexive, symmetric and transitive, such a relation is called an equivalence relation. Now, let us define an equivalence relation. How to define equivalence relation? A relation R on a set A is called equivalence relation if R is reflexive, symmetric and transitive. If R is reflexive, symmetric and transitive, such a relation is called an equivalence relation. Let us come to the problem number 1. Take an example. This type of problems are very important. What is the problem given? Let T be the set of all triangles in a plane. Set of all triangles in a plane where R is a relation on T is given by R is equal to T1 comma T2. What is the condition? T1 is congruent to T2. That is, R is equal to T1 comma T2 such that T1 is congruent to T2. Show that R is an equivalence relation. So, definitely you can say this is an equivalence relation because on the set of triangles, each triangle is congruent to itself. So, reflexive, if one triangle is congruent, if T1 is one triangle which is congruent to another triangle T2 means T2 is also congruent to T1, symmetric, and as usual transitive. If one triangle T1 is congruent to T2, T2 is congruent to T3, definitely it is congruent to T3. So, just by looking to the problem, you can say that this is a equivalence relation. That means it will satisfy all the 3 conditions: reflexive, symmetric and transitive. Let me explain the reflexive property. What is reflexive? R is reflexive since every triangle is congruent to itself, because if T1 is comma T2 belongs to R means T1 is congruent to T1. Therefore, R is reflexive. Every triangle is congruent to itself. That is, T1 comma T2 belongs to R means T1 is congruent to T2. That means the condition A comma A belongs to R is satisfied. A comma A belongs to R. Therefore, This is reflexive. Now move on to the second one, symmetric. What is symmetric? So R is symmetric since T1 comma T2. If triangle 1 and triangle 2 belongs to R, that means if T1 is congruent to T2, definitely T2 comma T1 also congruent. Since T1 comma T2 belongs to R implies T2 comma T1 also belongs to R. That is, if T1 is congruent to T2 implies T2 is also congruent to T1. That is, T1 comma T2 belongs to R implies T2 comma T1 also belongs to R. Therefore, R is a symmetric. See, if this is one triangle, this is T1, this is congruent to T2, another triangle. So, T1 is congruent to T2, definitely 2T is also congruent to T1. So, therefore, it is a symmetric. Now, let us come to the transitive property. Here R is transitive since T1 comma T2 belongs to R and T2 comma T3 belongs to R implies T1 comma T3 also belongs to R. That is, if T1 is congruent to T2 and T2 is congruent to T3 implies T1 is also congruent to T3. Therefore, R is a transitive. That is, if there are three triangles, this is T1 and T2 and T3. So, if T1 is congruent to T2 and T2 is congruent to T3, definitely T1 is also congruent to T3. Therefore, R is a transitive. Hence, this relation satisfies all the three properties, reflexive, symmetric and transitive. Therefore, R is an equivalence relation. Right. Now, move on to the next problem. So, a relation R on the set of natural numbers is defined as R is equal to x comma y such that y is equal to x plus 5 and x is less than 4. Determine whether the relation is reflexive, symmetric and transitive. This is also same. Now, what is given here? X is less than 4 implies x is equal to, x can take the values 1, 2 and 3. And what is the condition given? Y is equal to x plus 5. Now, what is the relation? Just write down the relation. So, when x is equal to 1, what is y? Y is equal to 1 plus 5, that's equal to 6. So, therefore, the relation R contains first element as 1 comma 6. When x is equal to 2, when x is equal to 2, what is y? Y is equal to 2 plus 5 is equal to 7. So, then we will get 2 comma 7. When x is equal to 3, when x is equal to 3, what is y? Y is equal to 3 plus 5 is equal to 8. Then this is 3 comma 8. These are the elements of the set R. See here. So, if x comma y such that y is equal to x plus 5 where x is less than 4. X is less than 4 means the values of x are 1, 2 and 3. So, take x is equal to 1 plus 5. 1 plus 5 is equal to 6. Again x is equal to 2. 2 plus 5 is 7. X is equal to 3. 3 plus 5 is 8. Where x belongs to the set of natural numbers. 1, 2, 3 are the natural numbers. Now, here the relation is 1 comma 6, 2 comma 7 and 3 comma 8. Straight away you can say this is neither reflexive nor symmetric nor transitive. See here, one R is not reflexive. R is not reflexive. This is not reflexive. What is the reason? Because A comma A does not belongs to R. That means 1 comma 1 or 2 comma 2 does not belongs to R. This is not a reflexive. 1 comma 1, 2 comma 2 does not belongs to R. Next, reflexive. Symmetric. What is symmetric here? This is not symmetric. R symmetric. R is not symmetric. Not symmetric. This is not symmetric. What is the reason? Because 1 comma 6 belongs to R implies 6 comma 1 does not belongs to R. Right. 2 comma 7 belongs to R, but 7 comma 2 does not belongs to R. 3 comma 8 belongs to R. 8 comma 3 does not belongs to R. Not symmetric. Not reflexive, not symmetric. Now move on to the next property, transitive. What is transitive? Third one, transitive. What is transitive? If A comma B belongs to R and B comma C belongs to R, implies A comma C also belongs to R. Let us take no element will satisfy this. So, this condition A comma B implies if A comma B belongs to R and B comma C belongs to R, implies A comma C does not belongs to R. Therefore, R is not transitive. R is not transitive. What do you say? Hence this is neither reflexive nor symmetric nor transitive, hence this is not an equivalence relation. That is, so this is neither reflexive, symmetric nor a transitive. That's it. Okay. Now move on to the next problem. Show that the relation R on the set Z of integers is given by R is equal to A comma B such that 2 divides A minus B is an equivalence relation. So what is the condition? 2 divides A minus B is an equivalence relation on the set of integers. So straight away you can say this is an equivalence relation. Now let us verify whether it is reflexive or not. R is reflexive because 2 divides A minus A. What is A minus A? 0. 2 divides 0. That is A minus A. That is A minus A is equal to 0. So that means 2 divides A minus A implies 2 divides 0. So 2 divides 0. That means therefore R is a reflexive. That is A comma A belongs to R implies 2 divides A minus A. That is 2 divides 0. Therefore R is a reflexive on Z. Now next, reflexive, symmetric. So R is symmetric because if A comma B belongs to R, that means 2 divides A minus B. 2 divides A minus B means then 2 also divides B minus A. That is, if 2 divides A minus B, then 2 also divides B minus A. That means A comma B belongs to R implies B comma A also belongs to R. Therefore R is a symmetric. Now the third one is transitive. This is transitive because R is transitive as A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R. See, just if 2 divides A minus B and B 2 divides B minus C implies 2 also divides A minus C. Let us add this because A minus C is nothing but A minus C can be written as A minus B plus B minus C. So minus B plus B gets cancelled. See, this is A minus B plus B minus C plus B minus C gets cancelled, A minus C. That means 2 divides A minus C. So therefore 2 divides A minus C means A comma C also belongs to R. So therefore we can say that R is transitive, hence R is reflexive, symmetric and transitive is an equivalence relation. So it's very simple. 2 divides A minus A, 2 divides 0. 2 divides A minus B implies 2 also divides B minus A, that is symmetric. First one is reflexive, second one is symmetric. Third condition, if 2 divides A minus B and 2 divides B minus C, minus B plus B gets cancelled, 2 also divides A minus C, that means it is also transitive. That means the relation R given by 2 divides A minus B is an equivalence relation. This is an equivalence relation on Z. This type of problems are very, very important for 3 markers. Now let us take one more 3 marker example. This is very, very important problem indeed. Determine whether the relation R on the set A is equal to 1, 2, 3, etc. up to 14 is given by or is defined by R is equal to x comma y such that 3x minus y is equal to 0 is reflexive, symmetric and transitive. This is very important problem indeed. What is given here? A, the set A contains 1, 2, 3, etc. up to 14. What is that condition given? 3x minus y is equal to 0, which implies 3x is equal to y. That means y is equal to 3x. Here x comma y can be written as x comma 3x. Just write down the elements of x comma 3x, that's all. So when x is equal to 1, y is equal to, when x is equal to 1, y is equal to 3 into 1, that's equal to 3. Similarly, when x is equal to 2, y is equal to 3 into 2 is 6. When x is equal to 3, y is equal to 3 into 3 is 9. When x is equal to 4, y is equal to 3 into 4, that's equal to 12. Suppose if x is equal to 5, if x is equal to 5, then what is y? 3 into 5 is equal to 15. 15 does not belongs to the set A. We cannot take. So only these are the values we are going to consider. So that is 1 comma 3, 1 comma 3, then 2 comma 6, then 3 comma 9, then 4 comma 12. These are the elements of the set R. So the relation R contains 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. So if you want, you can verify this condition. What is the condition? 3x minus y is equal to 0. 3 into x is 1, y is 3. 3 minus 3 is equal to 0. Even for this, 3 into 4 minus 12, 12 minus 12 is equal to 0. This condition is satisfied. Now, verify whether this is reflexive, symmetric or transitive. Now, this is not reflexive because 1 comma 1 does not belongs to R. So, first one, R is not reflexive. R is not reflexive because x comma x does not belongs to R. Here 1 comma 1, 2 comma 2, 3 comma 3 does not belong. So this is not reflexive. Second one, symmetric. R is not symmetric. R is not symmetric because 1 comma 3 belongs to R, implies 3 comma 1 does not belongs to R. Similarly, 3 comma 9 belongs to R, but 9 comma 3 does not belongs to R. Therefore, R is not a symmetric. And last one is the transitive. Verify transitive here. So, R is not transitive. Third one, R is not transitive. R is not transitive because let us take this. 1 comma 3 belongs to R and 3 comma 9 also belongs to R. 3 comma 9. So 1 comma 3 and 3 comma 9 belongs to R. So these are equal, but 1 comma 9 does not belongs to R. Right? 1 comma 3 and 3 comma 9 belongs to R, but 1 comma 9 does not belongs to R. A comma B belongs to R and B comma C belongs to R, but A comma C does not belongs to R. Therefore, this is not a transitive. So therefore, R is not, this is not reflexive, not symmetric and not a transitive. This is not an equivalence relation. So these are few types of problems you may expect for a final examination for 1 marker, 2 marker and a 3 marker. That's all regarding today's session. Let us discuss few more problems in the next session. Thank you very much.